Okay, in this problem, we're asked to find V0 using Thevenin's theorem, and let's note that V0 is the voltage across 6 kilo ohm resistor, and we're going to use our problem solving strategy entitled Applying Thevenin's theorem. And if we look at that strategy, since V0 is across this 6K resistor, we're going to remove the 6K resistor from the circuit, make a port, and we're going to find the Thevenin equivalent circuit of everything outside the box. And our Thevenin equivalent circuit then is a voltage source in series with a resistance. The open circuit, our Thevenin, here's the terminals A and B. Once we've calculated the Thevenin equivalent circuit, then we're going to come back in, hook up the 6 kilo ohm resistor to the Thevenin equivalent, and then we'll calculate the voltage V0. So that's our procedure. Remove the 6 kilo ohm resistor, find the Thevenin equivalent circuit, and then hook the 6K resistor back up. Now, if we note here, we've got both independent and dependent sources, so we're going to have to solve for the open circuit and I short circuit both. So let's now remove the 6K and look at how we would calculate the open circuit. So here's our circuit. Notice that we've removed the 6K resistor. And if we look, we have a single loop circuit now. And I'm going to define this current as I1 prime. And we'll go and solve for this current. Now, if we look at our circuit here and look at this voltage Vx prime, we can note from Ohm's law that Vx prime is 4K times I1 prime. So let's begin by applying Kirchhoff's voltage law to our single loop circuit here. So we have 4K I1 prime, that's the voltage across here, plus 4K I1 prime. Current I1 prime flows all the way around this loop. Then we have minus Vx prime over 2 equal to 12. And we collect terms here like 8K I1 prime minus 1/2, and now we're going to substitute in from up here for Vx prime. So now we'll have 4K I1 prime equal to 12. So we get 6K I1 prime equal to 12, or that I1 prime is equal to 2 milliamps. So now that tells us what the current is. Now if we look at VOC, what we'll do now is we'll apply Kirchhoff's voltage law around this loop to be able to find VOC. So applying KVL around this loop, we get VOC is 4K I1 prime minus Vx prime over 2, which is 4K I1 prime minus 1/2 4K I1 prime. And it turns out then that VOC is 2K I1 prime, so we have 2K times 2 milliamps, and that gives us an open circuit voltage of 4 volts. So that concludes our calculation of open circuit voltage. Now we're going to go into the circuit, and we're going to place a short from A to B and find the short circuit current. So here's our circuit that we'll use now for finding the short circuit current. So now we've placed a short between A and B, and we're looking to calculate our short circuit. Now let's look at that circuit. For instance, if we apply Kirchhoff's voltage law around this outside loop, we're going to get that Vx double prime is equal to 12 volts. Okay, so around this outside loop, Vx double prime has to equal 12 volts. Okay, then that tells me